Hello again. In this video, I'm going to go over Theorem 314, which is about the chain rule for powers. And so here's what the theorem says. If G is differentiable for all x in its domain, and P is a real number, then the derivative of G of x raised to the P power is equal to P times G of x raised to the P minus 1 power times G prime of x. Now, this theorem is actually derived from the chain rule itself. And I'm going to illustrate that by looking at an example. So let's say you have this function here and you want to find the derivative of it with respect to x. Now, the first thing you should recognize when you see this is that this is actually a composition of two functions. And you remember, anytime you take the derivative of a composition of functions, you have to use the chain rule. And remember, there's two forms of the chain rule. You could use either one to find the derivative. Now I'm going to use this form first. Now if you're going to use this form of the chain rule, you are going to have to write this function in terms of f and g, so that f composed with g is actually equal to this function. Now the easiest way to do that is to take the inner function here and call that g of x. And then that would mean the outer function would have to be x raised to the 21st power. Now, if you form the composition f composed with g, you will get this function. Okay, and now to find the derivative of that composition, the derivative of f composed with g is equal to f prime evaluated at g of x times g prime of x. Okay, so let's find f prime of x first. Of course, the derivative of this would simply be 21x raised to the 20th power. And now you have to evaluate this at g of x. Okay, where g of x is tangent of x plus 10. Okay, and now remember, when you evaluate this derivative at a number, what does it do to the number that you're evaluating it at? Well, it raises it to the 20th power, and then it multiplies it by 21. And so this is the number we're evaluating the derivative at. So it's going to take that number and then raise it to the 20th power and then multiply that by 21. So that's f prime evaluated at g, which is the outer derivative. And then we have to multiply that by the inner derivative, which is just g prime of x. Okay, so we need to find the derivative of this function. Well, the derivative of tangent of x, if you remember, is actually equal to secant squared of x. And then the derivative of 10 is 0 because that's a constant. Okay, so g prime of x is just secant squared of x. Okay, so then dy dx is just the outer derivative times the inner derivative. Okay, so we can find the derivative of this function using the chain rule, since it's a composition of two functions. But notice, you can also use the chain rule for powers, because it's a function raised to a power. And so the chain rule for powers basically says if that happens, the derivative of this function is simply 21. You take the 21 and you multiply it in front. So it's 21 times this function raised to the 20th power. So you subtract 1 from the power. And that's exactly what happened. right? So this is 21 times this function raised to the 20th power. And then you take the derivative of this inside function and you multiply by that. And of course, the derivative of this function is secant squared. So the chain rule for powers is not some mysterious thing that came out of nowhere. It actually comes from the chain rule itself. It's just a special case of the chain rule. In fact, you don't even need to think of theorem 314 as another theorem that you need to memorize. You can always just use the chain rule to find this derivative. Now, it does happen to fall into the special case where you can actually use theorem 314, but that doesn't really matter because if you think of this as the chain rule, as a chain rule problem, you'll still get the same answer. Now, you could have also used this second form of the chain rule. Now, if you're going to use this form to find the derivative, what you need to do is instead of writing this as f of x and g of x, so that f composed with g of x equals this function, instead of doing that, what you have to do is you have to write down y in terms of u, and then write down u in terms of x. And u is going to be the inner function, and this one's going to be the outer function. Okay, so u is going to be the inner function. The inner function is tangent of x plus 10. And then the outer function would be u to the 21st power. Now remember, you have to write y in terms of u. So we're going to write this as u to the 21st power, not x to the 21st power, but u to the 21st power. And that's because y has to be written in terms of u. Now you notice that when I plug this in for u over here, tangent of x plus 10, I do get this tangent of x plus 10 raised to the 21st power. Okay, and so now dy dx, using the chain rule, is just dy du times du dx. Okay, well, what's dy du? Okay, the derivative of y with respect to u would be 21u raised to the 20th, using the power rule. And then du dx would be the derivative of this function with respect to x, and of course that's just secant squared. And now we just want to replace this u with tangent of x plus 10. Okay, so we get tangent of x plus 10 raised to the 20th power times 21, and then times secant squared of x. Okay, and so notice you get the same answer. Okay, so to kind of put a cap on this, theorem 314, which is the chain rule for powers, would apply to this particular case. And so you could use that theorem to find the derivative of this function. But the chain rule for powers really comes from the chain rule itself. And so if you just apply the chain rule to this function, you're able to find the derivative that way as well. And you can use either form of the chain rule, and you'll get the same answer. Okay, so I hope you found this video helpful. Thank you for watching. Bye-bye.